Okay, so now we will discuss reciprocating engines. So what it is and how it works. So actually, reciprocating engines, it is kind of rare invention so far, and we used it. Usually, we use it for a lot of applications. If you think about the automobiles, you can say this is actually the powerhouse of the automobiles. Sometimes the lighter aircrafts, ships, the electric power generators, all of these or many other devices, engineering devices, actually use this reciprocating engine. In other words, you can say reciprocating engine is kind of piston cylinder device. Okay, so it's kind of piston cylinder device like this. So we'll try to introduce ourselves with this reciprocating engine, or in other words, the piston cylinder device. So this is actually the basic schematic, the design of the physical component of a reciprocating engine. We have a piston, we have the cylinder. So cylinder, piston, we have the valves. So here you will see we have the intake valves, exhaust valves. So we'll try to discuss actually how it works. So this piston, it usually operates in between these 2 points. This BDC, it is actually the bottom dead, the center. TDC, this is actually the top dead center. So if I write it down, it is top dead center, and this is bottom dead center. Okay, so during the piston, how the piston cylinder device works. Usually this piston moves and it go down due to the compression and the expansion respectively. So when we actually want to compress this, any gas or whatever it is, so during the compression process, the piston usually go up. It moves to the upward directions, and then definitely the volume will decrease due to the compression. This is actually the state here. So when it is the compression, you can see it's this piston actually it's going up, and the volume actually decrease. So this is actually the dead point, or the maximum point we can say, until the piston can move. So this is actually called the TDC, or the top dead center. When it expand, during the expansion process, it can go down to, let's say, up to this point. So the point where the piston usually stops during the expansion, we will say this is the bottom dead center. And the difference between, so piston usually travel in between this TDC and BDC. So the distance in between this TDC and this BDC in one direction, this distance is called the stroke of the engine. This is important. We will use this term stroke, 2-stroke engine, 4-stroke engine. So this stroke is actually the movement of the piston in between the BDC and the TDC. And the diameter of the piston, this is the diameter of the cylinder, it is actually so the diameter of the piston, it is called the bore, but we need to know actually the stroke. We need the better understanding of the stroke. We have two components here, intake valve and the exhaust valve. Intake valve actually used when we actually want to just take the air fuel mixture. So the air fuel usually drawn into the cylinder by using the intake valve, and the exhaust valve actually helps to expel the combustion products. So that's actually how it works. So now when it will be the compression, then the volume will decrease. In other words, we can say this is a clearance volume. During the expansion, the volume expand. We can say this is the displacement volume. So the ratio, we know the ratio of this clearance volume and the displacement volume, it is called the compression ratio. So the maximum volume Vmax and the minimum volume, So the ratio of this maximum and the minimum volume, it is called the compression ratio, and we usually define by using the term R. So R is actually the compression ratio. In future, when we'll discuss the the SI engine, the CI engine, then we'll use these terms again and again. So we're trying to introduce ourselves with this term. So SI engine, the reciprocating engines, it can be discussed two ways. One is the spark ignition, SI, and the compression ignition, CI engine. So that we will do later on. So now there is another important component. What is the main effective pressure? Main effective pressure is eventually nothing but it is the ratio of the net work and the volume difference. So this is the net work and the difference of the volume, maximum and the minimum volume. Or you can say this maximum and the minimum volume, it is as a displacement volume. Okay. Now, so we'll discuss that on later. It's actually not the displacement volume. Displacement volume is something different. It is actually, we will calculate from here the piston area and the stroke. So multiplication of the piston area and the stroke. This is the displacement volume, but this is clearly the difference of the volume. So here, how you can see how we can calculate the net work output. The net work output is the main effective pressure and the displacement volume. So mean effective pressure, it can be used as a parameter to compare the performance of the reciprocating engine of equal size. Here you can see the MEP. So we'll discuss this on actually during the lecture. So in other words, we can say the net work. If you actually want to calculate the net work, we need the MEP, and we need the the piston area and the stroke, or in other words, you can see the displacement volume. So we'll solve some problem, and then we will use all of these equations. So it was not that much important, but here actually we need to know how this reciprocating engine actually works and the physical components that we are going to use again and again. So that's it, and we'll discuss a bit more during the lecture.